2023 National Electrical Code, also known as the NEC, now requires the use of copper conductors for branch circuits that supply power to ranges and heat pumps. This change is a significant update in electrical codes affecting how these appliances are wired in residential and commercial settings. Article 422 of the NEC is where you'll find the specific requirements related to appliances, including ranges and cooking equipment. Section 422.14 specifically addresses branch circuits that feed ranges and cooking appliances. It clearly states that branch circuits supplying ranges and cooking appliances rated at more than 20 amps shall be copper. The implication here is that any range or cooking appliance drawing more than 20 amps must be wired using copper conductors. This ensures a safer and more reliable electrical connection for these high-demand appliances. The reasoning behind this requirement centers on the electrical properties of copper and its ability to handle the sustained current draw of these appliances. Copper has a lower resistance than aluminum, which is another commonly used conductor material. This lower resistance translates into less heat generation within the conductor itself, reducing the risk of overheating and potential fire hazards. Ranges and heat pumps, by their nature, operate for extended periods and draw significant amounts of current. The heat generated by aluminum conductors under these conditions can lead to degradation of the insulation and even melting of the conductor itself. Copper's superior conductivity and heat dissipation characteristics mitigate these risks. Similarly, Article 440 of the NEC deals with air conditioning and refrigeration equipment, including heat pumps. Section 440.30 explicitly requires that branch circuits supplying heat pumps shall be copper. This requirement is consistent with the rationale for ranges and cooking appliances, as heat pumps also draw considerable current and operate for extended durations. The consistent application of copper conductor requirements across both ranges and heat pumps reinforces the NEC focus on safety and reliability in electrical installations. When installing or upgrading electrical systems for ranges and heat pumps, it's essential to adhere to these updated code requirements. Using copper conductors of the appropriate size ensures compliance with the NEC and provides a safer electrical system. Failure to comply with these requirements can result in code violations, potential safety hazards, and increased risk of electrical fires. Understanding the specific requirements outlined in Article 422 and 440 is crucial for electricians, contractors, and homeowners involved in electrical work. Consulting the 2023 NEC Handbook and seeking guidance from qualified electrical inspectors can help ensure compliance and promote electrical safety. The NEC guidelines are not simply suggestions, they are legally enforceable standards that dictate how electrical work must be performed to ensure public safety. The requirement for copper conductors extends beyond just the conductors themselves. It also impacts the selection of electrical components such as circuit breakers, receptacles, and wiring connectors. These components must be rated for use with copper conductors and be capable of handling the current load of the appliances they serve. Furthermore, proper installation techniques are critical to ensure the integrity of the electrical system. This includes making secure and reliable connections, using appropriate wiring methods, and protecting conductors from physical damage. The use of antioxidant compounds on copper connections is also recommended to prevent corrosion and maintain a low resistance connection over time. The NEC also provides guidance on the sizing of conductors for various applications. The ampacity, or current carrying capacity, of a conductor must be sufficient to handle the load of the appliance it serves. Factors such as the ambient temperature, the number of conductors in a raceway, and the type of insulation used can all affect the ampacity of a conductor. The NEC provides tables and formulas to help electricians determine the appropriate conductor size for a given application. For example, NEC Table 310.16 provides ampacity ratings for insulated conductors rated up to 2000 volts, based on conductor size, insulation type, and ambient temperature. It is important to consult this table and apply the appropriate correction factors to ensure that the selected conductor has sufficient ampacity for the intended load. The requirements for copper conductors in range and heat pump circuits reflect a broader trend in electrical codes towards enhanced safety and reliability. As electrical systems become more complex and appliances become more power-hungry, the need for robust and reliable wiring methods becomes increasingly important. The NEC is constantly evolving to address these challenges and incorporate new technologies and best practices. Staying up to date with the latest NEC requirements is essential for anyone involved in electrical work. This includes attending training courses, reading industry publications, and consulting with qualified electrical inspectors. By adhering to the NEC and employing sound electrical practices, we can help ensure the safety and reliability of electrical systems for years to come. The transition to requiring copper conductors for specific applications is not without its considerations. Copper is generally more expensive than aluminum, which can increase the initial cost of electrical installations. However, the long-term benefits of using copper, such as increased reliability and reduced maintenance, can outweigh the initial cost difference. Moreover, the cost of a potential electrical fire or equipment failure far exceeds the cost of using copper conductors. In addition to the cost factor, there are also environmental considerations associated with the extraction and processing of copper. However, copper is a recyclable material, and efforts are being made to promote sustainable mining and manufacturing practices. The electrical industry is also exploring alternative conductor materials and technologies that could potentially offer similar performance characteristics as copper at a lower cost and with reduced environmental impact. These include advanced aluminum alloys, carbon nanotubes, and superconducting materials. However, these technologies are still in their early stages of development and are not yet widely adopted in mainstream electrical applications. In the meantime, copper remains the preferred conductor material for many applications due to its superior electrical and mechanical properties. The 2023 NEC emphasis on copper conductors for ranges and heat pumps underscores the importance of using high-quality materials and employing sound electrical practices. By adhering to these requirements, we can help ensure the safety and reliability of electrical systems and protect people and property from the hazards of electricity. Now let's delve a bit deeper into the practical implications of these NEC requirements. When dealing with ranges, it's crucial to understand the appliance's power requirements. The nameplate on the range will specify the voltage, amperage, and wattage. Use this information to calculate the required conductor size, taking into account the NEC ampacity tables and correction factors. For example, if a range is rated at 120/240 volts and draws 40 amps, you'll need to select copper conductors with an ampacity of at least 40 amps. You'll also need to choose a circuit breaker that is appropriately sized to protect the circuit. The NEC typically allows for a circuit breaker to be sized at 125% of the continuous load. In this case, 125% of 40 amps is 50 amps. So, you'd likely use a 50 amp circuit breaker to protect the range circuit. When working with heat pumps, the same principles apply. Determine the heat pump's voltage, amperage, and wattage from the nameplate. Then calculate the required conductor size and circuit breaker size, adhering to the NEC guidelines. Heat pumps often have multiple motors and components, so it's essential to consider the total load when sizing the conductors and circuit breakers. The NEC also provides specific requirements for the disconnecting means for ranges and heat pumps. A disconnecting means is a switch or circuit breaker that can be used to de-energize the appliance for maintenance or repair. The disconnecting means must be readily accessible and located within sight of the appliance. This allows the service technician to safely disconnect power to the appliance before working on it. In the case of ranges, the branch circuit switch or circuit breaker may serve as the disconnecting means, provided it is readily accessible. For heat pumps, separate disconnecting means is typically required, such as a fuse disconnect switch located near the outdoor unit. When installing copper conductors, it's important to use appropriate wiring methods. The NEC specifies various wiring methods that are permitted for different applications. These include non-metallic sheet cable, metallic conduit, and cable tray. The choice of wiring method depends on factors such as the location of the wiring, the type of building construction, and the environmental conditions. Non-metallic sheet cable, also known as Romex, is commonly used for residential wiring. It consists of insulated copper conductors enclosed in a non-metallic sheath. Metallic conduit, such as EMT or rigid conduit, provides greater protection for the conductors and is often used in commercial and industrial settings. Cable tray is a system of supports that is used to run large quantities of cables in commercial and industrial facilities. Regardless of the wiring method used, it's crucial to install the conductors properly to ensure their long-term reliability. This includes supporting the conductors at regular intervals, protecting them from physical damage, and making secure and reliable connections. Proper grounding is also essential for electrical safety. The NEC requires that all electrical equipment be properly grounded to provide a path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse in the event of a ground fault, preventing electrical shock hazards. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel with a grounding conductor. All metal enclosures and equipment must be bonded to the grounding system to ensure that they are at the same potential as ground. When working with copper conductors, it's important to use connectors that are specifically designed for use with copper. These connectors are typically made of copper or a copper alloy and are designed to provide a secure and reliable connection. Using connectors that are not compatible with copper can lead to corrosion and eventual failure of the connection. It's also important to use an antioxidant compound when making copper connections. This compound helps to prevent corrosion and maintain a low resistance connection over time. The antioxidant compound should be applied to the bare conductors before making the connection. In addition to the technical aspects of installing copper conductors, it's also important to follow safe work practices. Always to energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can be dangerous, and it's not worth risking your safety to save a few dollars. The 2023 NEC requirement for copper conductors in range and heat pump circuits is a significant change that reflects the ongoing evolution of electrical safety standards. By understanding these requirements and following sound electrical practices, we can help ensure the safety and reliability of electrical systems and protect people and property from the hazards of electricity.